Now we are taking a few examples of electrolysis, right? As you are familiar with the term electrolysis now, that is the phenomena in which we pass electric current through an electrolyte, and as a result electrolyte just split into ions, and you know that the different kind of ions, that is the cation and the anion, just migrate to the opposite poles, and like accordingly oxidation and reduction occurs at cathode and anode, right? So I will just explain you by taking few examples, and I will also explain you that how it differs, like how electrolysis actually differ for a molten one or an aqueous solution, right? So I am taking into the consideration the first example, that is the sodium chloride, right? So see, I have two figures, one on this side and one on this side, right? There is no difference in the figure as such. There are electrodes, right? There is a battery, there is a key, even here is a key, right? And the graphite electrodes, again a graphite electrodes. What is the difference is that it has an electrolyte, and similarly it has an electrolyte, but it differs in the nature of the electrolyte. What is that? See, it is a molten NaCl and it is an aqueous NaCl. So that means when we have molten NaCl, or we can say when we have a molten electrolyte and when we have a aqueous electrolyte, there occur a few differences in the electrolysis. So just look at the board and just try to recall it, and try to just go into the depth of the reason, what is the main cause for it, right? So just look at the first figure, that is the electrolysis of the molten NaCl. So what is going to happen when we will pass electric current from the NaCl? We know that on passing the electric current, electrolyte split into ion. So here we have a molten electrolyte, so again it will split up into an ion. So that means what kind of ion? Na positive and Cl negative, that is the cation and anion. And you know that they move to the respective electrode, that means the oppositely charged electrode. That means Na will move to cathode and Cl will move at anode, right? And accordingly they will just, there will be a chemical reaction that will occur, like a reaction at cathode. So who is going to move at cathode? Na positive. Na positive means it has just lost one electron. So what it will do? It will gain its electron, and you know that gaining of electron is called as reduction, right? So because it has one positive charge, so that means it has lost one electron. So it will just now again regain its one electron. So just see what I am writing. Plus means I am adding one electron. So either write one electron, and if you don't write anything, you know that if nothing is written in front of an alphabet, it means, obviously it means one. So you can write one, or you can leave like that also, right? So it will gain one electron and it will turn into an atom, and it will be a pure form. So this kind of reaction is going to occur at cathode, that is for this ion. And similarly, what reaction do we get for an anion? So what reaction occur at anode? Cl negative ion. Now what do you mean by Cl negative? Negative means that it has gained one electron. So what it will do? It will just, what the number of electron which it has gained earlier, it will now be losing that electron. So how many electron it has gained? See, you can you see one negative charge, so that means it has gained one electron. So what it will do? It will just lose that gained electron, and what is that? That means the one electron. So just see, what am I writing? Minus, that means it is losing back. How many electrons? One electron, and again it will form an atom, that means the chlorine atom. And as you know that chlorine is a diatomic molecule, that means it is not a monatomic, it doesn't exist as Cl in nature. It exists in a gaseous form, that is Cl2. So that means many atoms of oxygen, that means two out of them, all two will combine to form Cl2. That means what we will get? We will get Cl2 gas liberated at anode. What kind of reaction it has taken place on the anode? Obviously it is the the losing of electron, that is the oxidation. So this is how we have to carry out the electrolysis of the molten NaCl. So just I will write it down as I have done it. I will just write in the figures. It will be a recap. So that means NaCl will form Na plus Cl negative, as I have done in this case on passing electric current, right? You have to close the key, these electrodes will pass and NaCl will just break up into, I will just put the arrow because earlier it was indicated that this is electrolyte, but now I am just indicating it with the reaction. So NaCl just on passing electric current breaks into Na and Cl negative. Right, we know that the electrode which is attached to the positive electrode is anode and one which is attached to the negative terminal is cathode, right. So out of this, which ion will move at cathode and which ion is going to move at anode? See, it is positively charged ion, so obviously it will go on cathode. So it is just going on cathode. So all Na positive will rush towards cathode. I'll just show it with the fingers, right. And these ions will rush to the anode. They will just move to the oppositely charged electrode. Now, what happens when they reach here? When they reach here, they just Na positive means it has lost one electron. It will gain its one electron and it will form Na, right? And what Cl will do? Cl negative will lose its one electron and form Cl, and Cl will combine to form Cl2. So this is how the electrolysis will take place in case of molten NaCl. Now, what is the difference between the electrolysis of the molten NaCl and the aqueous one, right? So just look at the board carefully. What happens? Now we have aqueous NaCl. So that means on aqueous means it has NaCl and along with that there is a water too, right? So that means when we will pass an electric current, the both of them will get dissociated. So that means it will form Na positive and Cl negative. Similarly, it will form H positive and OH negative, right? Because both on passing electric current just dissociate to form an ions. So this is how they just form the respective ions. Now, both the positive charge, like this positive one and this positive one, they will move to the negatively charged electrode, that is the cathode. Again, this is the cathode, this is the anode, right? So they will move toward anode, and both of them will going to move at anode. Right. So that means Na positive, I will write in figure as well. So Na positive and the H positive, they are rushing towards cathode, right. And Cl negative, I will just write with another pen. Cl negative and OH negative will rush towards the anode, right. And you know that accordingly the oxidation reduction occurs. But now the question here arises that out of Na and H, Na ion and H ion, which is going to get reduced? You know that at cathode reduction occurs, right? That means they gain their electron which they have previously lost, right? So that means they will be gaining their electron back. So out of Na and H ion, which is going to just gain an electron? So will they both will be showing reduction, or any one of them will be showing? So you should know that if more than one ion just reach to the respective electrode, then that ion gets discharged whose reduction potential is low. I am just repeating again. If more than one ion rush to an electrode, like in this, the two ions are rushing to this electrode and two ions are rushing to this electrode, like so, out of them that ion is going to discharge which has the lower electric potential, or you can say the lower reduction potential. So as I have told you on cathode, so let us see out of them which has the lower reduction potential, which is going to show reduction, and out of them which has the lower reduction potential and which is going to show the oxidation. So reaction at cathode, so out of this Na and H ion, which has the low reduction potential? Obviously it is the hydrogen ion. So that means Na and H ion both will go to the cathode, but out of them only the reduction, which ion will be reduced? Only the hydrogen will be reduced. So that means these hydrogen ion with positive charge will gain its electron, form hydrogen. We know that hydrogen is a diatomic gas, so obviously like the Cl became Cl2, thus likewise the hydrogen will form H2. So that means what kind of reaction we'll get to see? We'll get to see H, H plus H, that is H2. So that means at cathode, which gas is liberated? The hydrogen gas is liberated. And what reaction do we observe at anode? As I have told you that these two ions just move at anode, and out of them, which has the lower reduction, lower electric potential or the reduction potential. So out of them, this has the chloride ion has the lower reduction potential. So that means out of these two ions, which is going to show the oxidation? Obviously, it is the chloride ions. So that means the reaction at anode is going to be the Cl ion negative. That means it has gained one electron, will be losing an electron, will be forming Cl, right? And as I have told you, Cl exists as a diatomic molecule. So that means Cl plus Cl just unite to form Cl2. So this is how you can say the reaction is going to take place, and this is the oxidation. I am just showing in the figure as well. So out of them, this hydrogen has the lower reduction potential, and out of Cl negative and OH negative, Cl has the lower reduction potential. So that means this Cl negative will lose an electron, forming Cl, and Cl and Cl will just unite to form Cl2. So here is a difference which you can easily see, that what is the difference that exists between the molten NaCl, electrolysis of molten NaCl, and electrolysis of the aqueous NaCl, right? So what is the actual difference what you predicted? It was that in this case there was no water, like it was molten in state, and in this case the water was present. So like this electrolyte got dissociated, so even the water got dissociated, and as the more than one type of ion just moved to an electrode, and the ion, I am again repeating, if more than one type of ion moved to an electrode, then the ion which has the lower electric potential is discharged, as out of Na and H, H has the lower electric potential. So that is why the reduction occur only for the H ion, right? And similarly in this case, the chloride ion has the lower reduction potential, that is why it is being oxidized, not the hydroxide ion. So this is how the difference lies. We will be taking few more examples. So just look at the board, we will be doing another example, that is the second example for the electrolysis.